So we're going to continue our work with the coordinate plane today, and our learning target is going to be I can find lengths of a polygon on the coordinate plane by using absolute value. So if you take a look at our solve and share says draw a polygon with vertices at A, -1, 6, B, -6, 7, 6, C, -7, -3, and D, -1, -3. Then find the perimeter of the polygon and then solve this problem any way that you choose. So first thing we're going to do is we're going to go ahead and we're going to mark our points, and then we're going to go from there. So the first point that I'm going to mark is point A, which is -1, -6. So -1, -1, 6 is going to be up here. So I'm going to go ahead, I'm going to mark it, and then I'm going to label that A. And then I'm going to mark B, which is -7, 6. So it's going to be on the same spot because my y quarter is the same, or my y quadrant's the same. So that's going to be B. Whoop, big B. And then I'm do -7, -3. So it's going to stay on the same x coordinate line. So -7, -3. And I'm going to mark that C. And then D is going to be -1, -3. So D, -1, -3. So I'm going to mark that D. So I'm actually going to find the polygon without, or finding the perimeter without doing any counting, because I'm going to go ahead and I'm going to use my absolute value to find the side length. So the first thing I'm going to do is I'm going to find the side length of side BA. So I'm going to look for the side length for side BA. Now when I do that, I'm going to go ahead and I'm going to use my absolute value. So the absolute value, they both share the same y coordinate because they're on the same horizontal line. So I'm going to look at the difference between my x coordinates. So I have -1, -7. They're in the same quadrant. So I'm going to subtract. So I'm going to do the absolute value of -7, subtract the absolute value of -1, and I end up with 6. So the side length of BA is going to be 6. Now, if this side length is going to be 6, that means the side length for CD is also going to be 6. Now I need to find the side lengths for BC and AD. So points B and C, they're on the same vertical line. That same vertical line means I have the same x coordinate. I have -1, or sorry, -7 is my x coordinates that are the same. So I'm going to look at the different ones. So I have 6 and I have -3. So 6 and -3. So I'm going to do the absolute value of 6 plus the absolute value of -3, and I get 9. So my coordinate for B, or my side length for BC, is going to be 9 units, which means my side length for AD is going to be 9 units. So to find the perimeter, now all I need to do is I just need to go ahead and I need to add. So 6 and 6 is 12, 9 and 9 is 18. So the perimeter that I have for this polygon is going to be 30 units. So that's what we're going to be doing today, is we're going to be using our absolute value to find side lengths of polygons to help us to determine perimeter, or to determine where the other point needs to be on a side line if I'm missing a vertice. So the vertice is where two lines or 2 points connect. So A and D had the vertice where those two lines are going to connect. Okay, so we're going to go ahead and we're going to take a look at your next page. So your next page says, how can you find the perimeter of a polygon on a coordinate plane? So we're really going to be looking at that polygon practice. So we have a map that we're going to be looking at. It says an archaeologist used a coordinate plane to map a dig site. She marked the corners of a building with flags as shown. So here's my corners of my building. They're marked with the flags as shown. So the vertices are where two lines intersect. So here's my vertice A, vertice B, vertice C, vertice D. How much rope does she need to go around the building? So again, looking at perimeter, we're looking at around the building. Perimeter is around. Okay, so we're going to use what we know. We're going to use that absolute value. So the first thing I'm going to do is I'm going to look at what the coordinates are. So we'll just start with point B. So B, the coordinate for B, if I look at this, is going to be, so 1, 2, I'm going to go over 2 and up to 6. So it's going to be 2, 6, point C is on the same line, so my x coordinate is going to stay the same. So it's going to be 2, 1, because I only went up 1 point here. D is on the same horizontal line, which means it has the same x or same y coordinate. And then I am -4, 1. And then point A is going to be, I'm on the same line as D, so it's going to be -4 and then 6. So you'll notice that because I have a four-sided polygon, so I have a quadrilateral, that coordinates all have values in common. B and C share the same x coordinate. D and A share the same x coordinate. C and D share the same y coordinate. And then B and A share the same y coordinate. So that's going to be something that's going to be helpful as we continue to go through. So I'm going to go ahead and I'm going to find side lengths of my 4 sides just to see where we're at, and then we'll find our perimeter. So first thing I'm going to do is I'm going to look at A and B. So A and B, they are in a different quadrant. 6 is the same, so I'm going to look at -4, 2. So side length AB is going to be equal to the absolute value of -4 added to the absolute value of 2 for a unit measurement of 6 meters. Now I got meters because right here it tells me that one of those spaces is equal to 1 meter. So I'm not going to use units this time. I'm going to actually use meters because they defined what it is. So we need to be able to read that map as we go. And let me just double check that my value for DC, their parallel, is going to be the same as well. So DC, I have the absolute value of -4 added to the absolute value of 2, and I get 6 meters as well. Now I'm going to do my next line segment I'm going to do. So I did AB, I did DC, I'm going to do AD. So my line segment for AD, A is going to have -4, D is going to have -4. So I'm coming over here and I am in the same quadrant. So I'm going to subtract here. So I'm going to do the absolute value of 6, subtract the absolute value of 1, and I end up with 5 meters. Okay, now the last one that I'm going to check is I'm going to check BC. So BC I have, again, so C I have 1, B I have 6, so I'm going to do the absolute value of 6, subtract the absolute value of 1, and I get 5 meters. So when I add all 4 values up, 6 and 6 is 12, 5 and 5 is 10, so I have a total of 22 meters is what my perimeter is equal to. So again, I'm using that absolute value to find my perimeters. I could count, but as we talked about in our last lesson, counting is not always going to give you an accuracy. This one it would be because my units are nice and one. They're one apart, but when I start doing rational numbers, that tends to be where we start having the issues with counting and making sure that they are the right spaces. Okay. So it says, how could you use what you know about the formula for perimeter of a rectangle to find the perimeter of using 2 of the distances? So we know that perimeter of a rectangle, we talked about this, equals 2L plus 2W. So I could just use 2 coordinates to figure it out. So I could really just use BC, and then I could use CD to figure it out, because here my length is going to be 5, my length is going to be 6. So if I just substituted 2 times 5 plus 2 times 6, I end up with 10 plus 12, which gives me 22 meters. So I can solve it if I know my formula. I can solve it just using 2 of the coordinates. Okay, go ahead and go to your next page. Let's take a look at some of our problems. It says, in the problems on the previous page, why do you add the absolute values for the distance from A to B and subtract absolute values to find the distance from B to C? So A to B, if you go back and you look on that page, we're adding them because A to B are going to be your different quadrants, and when we have different quadrants, we add. So different quadrants add. same quadrants, you subtract. So that's why we did that, because B and C are within the same quadrant. And so because they're in the same quadrant, we would subtract. It says number 2, could you use the method of adding or subtracting the absolute values of coordinates to find the length of a diagonal AC of rectangle ABCD? So this is a no. So when we have a diagonal, we are not dealing with distance anymore on a vertical line. We're dealing with distance on a diagonal line, which is going to be slope. And we've not learned slope yet. So they don't have the same coordinates. They don't have the same x or same y. So we cannot add or subtract the absolute value. Okay. Number 3 says, use the map of the archaeological dig site on the previous page. What is the perimeter of the rectangle with the vertices at point D, point C, then the food tent, and then the working tent? So if we go back and we take a look at what we have, point D, we had -4, 1. Point C, we had 2, 1. The food tent, so I'm just going to mark that with an F for right now. The food tent is going to be 2, and then looks like -2. And then the working tent, which I'm just going to mark with a W, is going to be -4, -2. So again, I'm going to use this to find my perimeter. So I'm going to start with going across. I'm going to do my line segment DC. And I really just need to find 2 of these. And then once I find 2 of these, I can plug in the perimeter. So line segment DC, we've already done this one. This one is 6 meters. So I'm going to use what I already know. And now I'm going to take a look and I'm going to do D to W. So I'm going to do my working food tent. So I have -4, -4. So I'm going to do 1, -2. So I'm going to have the absolute value of 1 plus the absolute value of -2, which is going to give me 3 meters. Okay, so I have 2 distances. I have 2 lengths. So I have my length and my width. So I'm going to do perimeter equals 2 times 6 plus 2 times 3, which 2 times 6 is 12. 2 times 3 is 6. So my answer is going to be 18 meters. So the perimeter of that new rectangle is going to be 18 meters. Okay, so I don't need a map to do this. I can find the perimeter of a rectangle just using my vertices. I'm going to look for, here's what's same. So I'm going to do line segment MP. So I'm just going to find 2 of them. So line segment MP. And I have 3, -2. So 3 added to -2 is going to be 5. So it's going to be 5 units because it didn't give me a unit of measurement. And then my other one that's going to be different is I'm going to do N and O. So NO, when I look at NO, I'm going to end up with the absolute value of, oh, well, here's what I'm noticing, -2, 3. So -3 plus -2, that's going to be the same as the one that we just did. So that's going to be 5 units. So I need to go ahead and I need to do one of my other ones. So I did M and P, I did N and O. So if I look here, I'm going to do O and P. So line segment O and P. And I have 3, -4, 3, 5. So -4 and 5 are in separate quadrants. So I'm going to do -4 plus 5, the absolute value of -4 plus the absolute value of 5, and I get 9 units. So that's all I need. Now I have 2 different line lengths. So I have 9 units and 5 units. So I'm going to do perimeter equals 2 times 5 plus 2 times 9. So 2 times 5 is going to be 10 plus 2 times 9, which is going to be 18, for a total of 18 units. Not 18, 28 units. And that's how I find it. I look for my 2 side lengths that are different. So here it was 9 units, here it was 5 units. If you do what I did here, where I end up with the same unit, find another point that's going to be different. You have 4 points to choose from. If you need to do all 4 lines